Software prototyping. Software prototyping. A software prototype is an initial version of a system used to demonstrate concept and try out design options. A prototype can used in the requirements engineering process to help with requirements elicitation and validation. In design processes, to explore options and develop a UI design. In the testing process, to run back-to-back tests. Next is benefits of prototype. Benefits of prototyping: improve system usability, a closer match to user real needs, improve design quality, improve maintainability, and reduce development effort. The process of prototype development. Establish prototype objectives, define prototype functionality, develop prototype, evaluate prototype. Prototype development. Prototype development may be based on rapid prototyping languages or tool. May involve leaving out functionality. Prototype should focus on areas of the product that are not well understood. Error checking and recovery may not be included in the prototype. Focus on functional rather than non-functional requirements such as reliability and security. Throw away prototype. Throw away prototype is a prototype should be discarded after development as they are not a good basis for a production system. It may be impossible to tune the system to meet non-functional requirements. Prototypes are normally undocumented. The prototype structure is usually degraded through rapid changes. Software design and implementation. Design and implementation. Software design and implementation is the stage in the software engineering process at which an executable software system is developed. Software design and implementation activities are invariably interleaved. Creative activity in which you identify software components and their relationship based on a customer's requirements. Implementation is the process of realizing the design as a program. Object-oriented design process. An object-oriented design process. Structured object-oriented design processes involve developing a number of different system models. They require a lot of effort for development and maintenance of these models, and for small systems this may not be cost-effective. Design models. Process. Design models. Design models show the objects and objects classes and relationship between these entities. Static models describe the static structure of the system in terms of object classes and relationship. Example of design models. Subsystem models that show logical groupings of objects into coherent subsystems. Sequence models that show the sequence of object interactions. State machine models that show how individual objects change their state in the response to events. Real-time design. Real-time design. A real-time software system is a system whose correct operation depends on both the results produced by the system and the time at which these results are produced. Time system modeling. Of simultaneous in a real-time system may trigger a transition from one state to another. State models are therefore used to describe embedded real-time systems. Soft real-time system. System whose operation is degraded if results are not produced according to the specified timing requirements. Real-time programming. Programming languages for real-time system development have the include facilities to access system hardware, and it should be possible to predict the timing of particular operations in these languages. Software reliability. Reliability and availability. Reliability, the probability of failure-free system operation over a specific time, given environment for a given purposes. Availability, the probability that a system at a point in time will be operational and able to deliver the request services. Perception of reliability. The formal definition of reliability does not always reflect the user perception of a system reliability. The assumptions are made about the environment where a system will be used may be incorrect. System reliability requirements. Functional reliability requirements define system and software functions that avoid, detect, or tolerate faults in the software and so ensure that these faults do not lead to system failure. The next one is software reliability requirements may also be included to cope with hardware failure or operator error. Reliability matrix. Reliability matrix are units of measurement of system reliability. System reliability is measured by counting the number of operational failures and where operate relating this to the demands made on the system and the time that the system has been operational. Software engineering. Importance of software engineering. More and more individuals in society rely on advanced software systems. We need to be able to produce reliable and trustworthy systems economically and quickly. It is usually cheaper in the long run to use software engineering methods and techniques for software systems rather than just write the program as if it was a personal programming project. Software engineering. The economies of all developed nations are depend on software. More and more systems are software controlled. Software engineering is concerned with theories, methods, and tools for professional software development. Expenditure on software represents a significant fraction of GNP in all deployed countries. Engineering is an engineering discipline that is concerned with all aspects of software production from the early stage of system specification through the maintaining the system after it has gone into use. Engineering discipline using appropriate theories and methods to solve problems, bearing in mind organization and financial constraints.